And you know that when it changed to red, it means that the original color is blue. Blue changed to red. It cannot be red changed to red, ma. What's the point? You cannot be green changed to red, ma. You don't have green paper, ma. So blue, blue changed to red. So let us move on to the acid and alkali indicators, which talks about indicator means what? Indicators comes from the English word indicate. Indicate. You know the indicate means what? Indicate means show. S-H-O-W. Show. We want to show whether or not that thing is acid or alkali. We will use an indicator. Alright, again I repeat, acid and alkali indicator. Indicator come from the English word indicate. Indicate means show. So we are here to show whether or not there is acidic property or alkali property, or both don't have. We call it neutral. So we are here to indicate. Alright. So if you haven't known, by the way, I don't know if I've taught before this in the previous slides. We have from the pH over to the left and to the right, to the most left pH, we call it acidic, acid, okay, acidic, Then you have the word in the middle called neutral, Then the one on the right side is alkaline, This is to describe whether or not it is acidic, alkaline, or a neutral, Neutral means it is pH 7, Alright, neutral means that it is pH 7, Alright, so if it's a pH 6.9 is neutral? No, 6.9 is acidic. Do you think 7.1 is neutral? No, 7.1 is alkaline. Only when exactly at 7.0 there is neutral. Exactly at 7.0 there is neutral. Alright, so let's see. Okay. Characteristics of different substances can be determined by using suitable pH indicators. That means for us to know whether a certain thing is an acid or an alkali, we will use suitable pH indicator. Alright, we call it a pH indicator. Alright, why? Because we may not know what are the substances sometimes. For example, you're in the science lab. Alright, you are the science lab. And then suddenly you mix around the test tube. You forgot, this test tube, this one I put acid or I put alkali. I forgot, no. This one I put sulfuric acid or hydrochloric acid. This one I put this one or that one. You know that if you use the wrong chemical, what will happen, right? You know what happens when you use wrong chemical in the science lab, right? You will either burn your face or you will burn down the whole science lab. You know that? You know that? So that is why you have to be very careful. If you have misplaced your acid and misplaced your alkali, or you wrongly label your acid and alkali, you have to go and test. You have to go and test what is what. If two things that are not supposed to mix together, you go and mix together, you are going to go home with only half a face. Okay? So you don't want that to happen. Alright? pH indicators, they are color indicators. Because later on when we study all the 4 pH indicators, they are all going to have their own color. They are all going to have their own color. So they are also color indicators that will change color according to the characteristic. So different characteristic will change the color differently. So for us, we want to observe, we want to see the changes in the color. From the original color, change to another color, maksudnya apa? From original color, change to other color means what? That is called identifying the characteristic. For example, original color, change to color A, I know what is going to happen. Original color, change to color B, I know what's going to happen. Original color, change to color C, I know what's going to happen. Original color remains unchanged, I know what's going to happen. Alright, so we want to observe the changes in the color. The color, the different result, the different color that change will show me the characteristic of the substance I am testing. Right? So your school lab, there are 4 pH indicators you will use. And you will be able to find your school lab. I believe any school lab will have. Of course, not only 4 pH indicators in this world, there will be more pH indicators, all right, in the better science lab, not your school science lab, not your school science lab, right? In other science lab, the big one, they will have other indicators. But for you, you only use these 4. First one, litmus paper. All right, usually it is in yellow color. Usually it's in red and blue color. All right. Or sometimes you will have what we call a pH paper. pH paper, all right, usually your school will not have because it is, I believe, not cheap to get. It's not cheap. Right? pH paper is not cheap to get. So, litmus paper, pH paper usually in the color of yellow color, all right, a bit of yellowish color, that is pH paper. Universal indicator is a liquid, all right, is a liquid, all right. So just litmus paper is a paper, solid one, is a liquid, is a solid, is a paper. Universal indicator is a liquid, all right, is a liquid. You have to drop the dropper as a liquid. Methyl orange is a liquid, all right, is a liquid. Phenolphthalein, liquid, all right, liquid. Okay, so let's see. Litmus paper, red or blue, and phenolphthalein, which is in the color of pink, are indicators that are made up of only one color. This means that there is only one color. Either original change to the other color, or original remains unchanged. Either red to blue, or red remains unchanged. Either blue to red, or blue remains unchanged. That's the litmus paper. Phenolphthalein. Either pink to white, as in colorless, or colorless to pink, or pink remain unchanged, colorless remain unchanged. That's all. You can only do that. Okay, only from one color change to the other, as in this color change to the opposite, or remain as the same color. That is what you call only one color. All right. So red litmus paper is one type, blue litmus paper is one type, phenolphthalein is one type, while the universal indicator are made up of a few colors. So let me let you see first what is the universal indicator. All right. So this one here, please look at here. This is the universal indicator. All the way from acidic side, red color, it will slowly turn orange, slowly turn yellow, slowly turn green. It will be exactly green at 7. Then start to have dark green, blue, darker blue, indigo, purple. Actually, is all the colors in the rainbow it has inside the universal indicator. All right. So this is very, very special indicator. All right, and it will be extremely expensive. All right, extremely expensive. All right, so you will probably not use this in school. Okay, because litmus paper is very cheap. Litmus paper is very cheap considered, compared to universal indicator. Of course, for students like you, they will use this litmus paper. All right, because you are not a scientist right now. You can be a scientist in the future, but you are not a scientist right now that can change the world yet. I'm not saying cannot, I'm saying yet. So that's why they give you litmus paper first. Just like when we are young, we also play with the toy first, cooking toy and all that. Doesn't mean in the future you cannot cook. Of course, some people, they still remain cannot cook. But of course, people normally they will be able to cook in the future. But when they are young, they will all play with the toy first, the toy kitchen, toy kitchen with all the pots, the plastic vegetable all. So in the future, you will have a chance to become a person who can cook. But some people remain unchanged, cannot cook. That is depends. For now, in the future, you may become very successful scientist. All right, you may be. Who knows? Because we are unpredictable. You may be a very successful scientist. But for now, you're not. That's why you play with the litmus paper first. You will not get to touch the universal indicator. All right. Now, pH indicator changes to a different color when placed in a solutions with neutral, acidic, or alkaline properties. So whenever you put the pH indicator into these liquid, solid, or gases, it will change into neutral, acidic, or alkaline properties. All right. Neutral, acidic, or alkaline properties. All right. pH indicators can only give a rough estimation of the pH value. That means what? That means they are not able to tell you pH 1, pH 2, pH 3, pH 8, pH 9, pH 10, pH 11. They even more cannot tell you pH 3.4, pH 4.6, pH 5.7. They even more cannot tell you 6.79, 8.32. They cannot tell you. Specific, they cannot tell you. They can only tell you an estimate. Estimate means what? Estimate means acidic or alkaline. That's all I can tell you. Acidic, neutral, or alkaline. Alright? Just like litmus paper. Blue to red, ma. Blue to red, alkaline. Acidic. Blue to red, acidic. Okay? But acidic is pH 0 to pH 7, no? As in 6.9. No? Do you think that the blue litmus paper turn to red can tell you pH what number? Of course, they cannot tell you. Because you test the blue litmus paper on pH 5, you will get blue change to red. If you take the blue litmus paper, test on pH 1, you will also get blue to red. But there are very big difference. 5 is lemon juice. 5 is lemon juice. Lemon juice. Drink, nothing happen. pH 1, battery acid can burn 2 holes in your throat. You can breathe through here, when it burn a hole in your throat. So don't think that you can take a litmus paper, all right, and you can tell the whole world anything is acid, anything is alkaline. Acid got pH difference. Alkaline also got pH difference one. All right, you can test, one can drink, one cannot drink, but you never know because the litmus paper give you the same observation. All right, same. The red litmus paper, red change to blue alkaline. Right? But pH 6, pH 8, it also changed red to blue. pH 13, also red to blue. But by the time you drink pH 13, you die already. Okay? That is why it can only give you a rough estimation. For you to get a very exact value, what you must use? You must use a pH meter, which will be the diagram on the right. This is a pH meter. So what happens is, it's usually a digital one, all right? And then there is going to be a place where, I believe there is a beaker here, if you can see, observe properly. There is currently a beaker with the blue, light blue colors liquid inside, where they are trying to dip this sort of like a needle, I believe some sort of tube into the liquid, all right, in order for the testing to start. And then it will go through the whole machine, go through the wires, all that. In the machine, it will detect, analyze, test, and then it will show you on the screen. So this one we know, pH 7.053. So that means this one is almost neutral. All right, almost neutral. All right, so it will show you very specific, pH 7053. But this sort of thing, this liquid, this light blue liquid, if you go and test with the universal indicator, you will get green. If you test with the litmus paper, you will not get any changes. Because you can only know that it is neutral, but you don't know how much neutral. Because 7.053 can be neutral. Okay, so 7 can be neutral. 7.053 can be neutral also. 7.01, 03 can be neutral. So we must know how much if you want to be very specific. All right, pH meter. That's your answer. All right, but this is just for you to know. I think rarely I see question asking about this. All right, so let us look at the few acid and alkali indicators. So the table above shows the litmus paper first. All right, a red litmus paper and a blue litmus paper. If you can see, red litmus paper, as we know, changes to blue when there is alkaline substance. All right, and the blue litmus paper change into red when there is acidic substance. For the rest, it will remain unchanged. All right, especially for neutral, you must remember neutral means they will not change any, because because red is to test alkaline, blue is to test acid. Okay, so when it is neutral, that means it is not acid and also not alkaline. That means there is no observation, there is no changes. That's why it says remain unchanged. Okay, so if it's a neutral, let's say normal water, you put red color, remain unchanged. Put blue color, remain unchanged. All right. But for this one, red color, of course, alkaline change to blue. The other one is remain unchanged. All right. For the blue, of course, acidic change to red. The other one, alkaline, remains unchanged. All right. And now here is this. This is where I want to show you. All right. How do you remember red and blue, acid and alkali? You see, Now I want you to remember only the result. Okay, I want you to remember the one here, the one that I have bolded. See carefully. See carefully. Is that okay? No need explanation. You can see for yourself. Whenever you see the result change into red, you know it's acidic, because red has a D, acidic has a D. Alkaline no D. Okay? And you know that when it changed to red, it means that the original color is blue. Blue changed to red. It cannot be red changed to red, ma. What's the point? You cannot be green changed to red, ma. You don't have green paper, ma. So blue, blue changed to red. Red, R-E-D, D, acidic. Acidic. Blue. You know the original color is red color. Cannot be other color. Cannot be black color. Only be red color. So red change to blue. Blue. L. Alkaline. 2L. Acidic, no L. Alkaline. L. That means when it changed to blue, that means it's alkaline. Red to blue, alkaline. Blue to red, acidic. Is that okay? Is that okay? So this one is just very simple for you to remember. You will never forget, trust me. Alright? When you go to up to Form 5, you will still remember tonight I teach you this. Alright? I guarantee you, you will still remember. Okay? Because this is how I remember throughout my entire life until now. Since primary school. Okay? So please remember this. Alright? Now, let's move on to the next indicator, which is methyl orange. Methyl orange only got 2 colors. It's actually 3 lah, because red changing to yellow, there is somewhat in the middle one, which is this orange color, because it's a gradient, gradient. Because red cannot suddenly yellow, cannot red, yellow, cannot like that, must be dark red, light red, start to get orange, dark orange, light orange, light yellow, yellow, dark yellow. Must be changed slowly. So that is why methyl orange, we don't call it 1 color, we call it 2 colors or a few colors. Alright. So what you must know is the red. By the way, using this is a very useful one, because you know that apart from the litmus paper, most of the indicators will show red on the acidic side and blue on the alkaline side. Alright, most. Okay, most. So what happens is, with what I told you just now, you will have known that methyl orange, when it is a red color, that means it's pH 1 to 3. Whenever it is getting closer to yellow color, alkaline, pH 4 to 14. Alright, pH 4 to 14. Alright, alkaline, or I would say more and more alkaline. Okay, so if you can see here, this is very special, this methyl orange. The reason is because the middle, as in the color doesn't change in the middle. Alright, the color doesn't change in the middle. You will see the orange color start to change here. That is why red color is only for pH 1 to 3, to the very acidic side. But yellow is going to be from 4 to 14. That means it is going to have acidic, neutral, and alkaline. Because the orange color start to change here. Orange color start to change here. Alright? And the yellow color start here. That's why you have to be very careful. You can only see which sort of yellow. Okay? You are only going to compare which sort of yellow. Is it light yellow or dark yellow? For you to see what number, what pH level. Alright? But when you see a red color, you know pH 1, pH 2, pH 3. When you see a little bit of orange, you know it's about pH 3. You see very dark red, light red, pH 1, pH 2. So that is methyl orange. And this is the reason why methyl orange is not very commonly used. Okay, we don't commonly use methyl orange. Is because there is very little, it's very hard to make observation. Because the pH, the color is very close to each other. You are very hard to make observation. Okay? Because if you see, compared to methyl orange, of course you use universal indicator is a much better choice. That is why some people, they don't choose to use methyl orange. Alright, it's okay? Next one. Alright, phenolpthalein. 2 colors, white to pink. Pink to white, or I would say colorless. Colorless means transparent. Colorless means transparent. Not white, not transparent. That means that it's clear. Or I would say clear. So when it is alkaline, it is showing pink color. Of course, at pH 14 is the maximum pink. Maximum pink. Then slowly it will start to fade away. It will get lighter and lighter. It will get lighter and lighter. Dark pink, light pink. Then start to get more and more transparent. And that is from alkaline going to acid. Alright. So for phenolphthalein, pink color shows alkaline. Colorless show you the acidic side. Colorless show you the acidic side. But of course, For this here, it is quite useless, I would say. All right, for this part here is quite useless. Because colorless, we are unable to differentiate. All right, because at pH 7, it will start to become colorless already, no? At pH 7, it already start to become colorless. So, since it's transparent, we are unable to see any difference. Either it's more transparent or less transparent because it is already 100% transparent. All right, throughout the whole pH 1 to 7 here, it's already, the whole thing is already considered transparent. So you are unable to see the difference. All right, so we are just going to take it as it is acidic. When you see phenolphthalein become clear, acidic lah. All right, so remember this phenolphthalein because you will see this phenolphthalein again in the last subtopic, neutralization. All right, in the neutralization, you will see this again, phenolphthalein. Okay, and now enough about that. Move on. Universal indicator. All right, 5 colors, or actually all the 7 colors in the rainbow: red, orange, yellow, green, dark green, blue, indigo, purple. So whenever you drip the universal indicator, I told you it's a liquid. When you drip it into the water, you will see a difference in the color. In fact, something is very immediate. You drop, it will change color. You drop, it will change color. So what happens is, towards more and more red, acidic. Just like how I taught you to remember the technique. More and more blue means that it is more and more alkaline. Green color, whenever you see green, when it starts to change to green, neutral. So that is universal indicator. So as you can see here, on the pH scale, this is what we call a pH scale, which is a set of numbers, all right, from 0 to 14. All right, the left side, below 7, acidic. Above 7, alkaline. And when you are closer to 0, it is more and more acidic. Right? When you are closer to 14, it is more and more alkaline. And at exactly 7, we call it neutral. All right, we call it neutral. So that is all for acid and alkali indicators where you will use throughout this entire chapter and more for the rest of your life.